let's move ahead into the Git, where we'll try to understand further on what are the details on how Git is architectured and how Git works and how is it different from other tools. So typically, if you can see the diagram over here on the left-hand side, now this is the centralized model which I was trying to explain you yesterday. That is this particular model, okay, where you have a server in which you have one particular repository onto which from different machines where the user have clients, they will be trying to do some changes and store the changes into the specific repository. So that kind of repository model where we are going to have one central server in which there will be only one repository and all the users have to do the changes and store into that particular central repository or a server. So this kind of model where we have a separate server and we have a client where users will try to do the changes and store into it is what we call it as a centralized model. Now, typically all the other SCM tools so far that we have in the market other than the Git, especially like Subversion, ClearCase, Perforce, or CVS, everything works on the same model called centralized model. But the problem with these kind of models that we go ahead is, the first thing is, since we have a separate server and a client from which a user will do the change, in case if a user wants to do some change, the operations will not be quick enough to get it done. That is because the central server can be obtained or should be available in a different zone. For example, let's say your organization's headquarters is present somewhere in US. So they will have the data center in US, and because of that, this central server on which the repository is residing could be somewhere in US. And now, as a user, when you are trying to work from your machine somewhere in India, then because of the network latency, there's going to be a lot of delay in doing the process. So that is when a simple checkout where you have 10 files or 100 files which you want to get it from the repository to your workspace is going to take a longer time. Now, consider about working on a product where you have 100 gig of storage or you have the data of 100 GB of your source code. So to do the simple concept of checkout, in order to just see the files, a user has to spend more than half an hour or 1 hour just to create a simple workspace. So that is when any kind of operations that you're going to do over the network is actually going to take a lot of time. The next problem is, since if you want to keep working on it, there always have to be a connection between the client and the server. So if there is a network outage, or if the network is not available, or in case if you are bringing your machine out of your network, then you cannot do any kind of the operation. So that is when you have a drawback where the client and the server, unless and until it is in connected mode, you cannot do anything else. So if it is not connected, then you cannot do anything. So that's the second problem. You can do the operations only if there is a proper network between the client and the server. And the third important thing is, it is not just one user who will be working. So there will be many users who will be having many clients, and each one of them will be doing changes from their own workspace or the client machine. Now, if one person as a developer or a user has to share his change with someone else, then first, he has to do a checkout and then do the changes, do a check-in so that it should get updated in the central server. And then the other user has to do a checkout once again. That's how he will be taking the latest changes, what this person has done to his workspace. And then on top of that, he has to do the change. So like this, if this person has to share his changes directly with anyone else, then he has to go through the same process where it is going to take once again a lot of time. So that is when working on a centralized model is actually time consuming, and it requires a lot of maintenance effort, and it is not much of a user friendly way. So what is that the Git is going to give as a solution for all these things? So that is when, if you try to understand, Git is also a version control system or a tool, but it doesn't work on a centralized model. So what is the difference between Git and any other tools? The first thing that you need to understand is, in Git, there is no concept of server or client. Once again, in Git, there is no concept of server or client. Now, that might lead a confusion to you that, okay, if you say there is no server, then where are you going to store everything? Because in the centralized model, we had a separate server in which we had repository, and that is where we were trying to store everything. But now, in Git, if I say you do not have a separate centralized server, then where is that you're going to store? So to understand this, the very first point that you need to understand is, in Git, everything is a workspace. Once again, in Git, everything is a workspace. Okay. So the first thing is, in Git, everything is a workspace. So now when I say everything is a workspace, every workspace now will have a copy of a repository inside it. Okay. So the second thing what you need to know is, every workspace will have a copy of the repository. Now, what do you mean by copy of a repository? Unlike in the previous model, when we were trying to discuss this, in the client where the user will create a workspace, you will be able to see only the files, right? But in Git, you do not have the server at all. All you have is only the workspace, where every user, when he creates a workspace, he will also get a repository inside it. So that is how, if you are trying to create a workspace to do some changes for a particular repository, then you are actually going to create a workspace in which you will also be getting additionally a small repository. Okay, so that is what is going to happen in Git. So that is why now every workspace in the Git will have a repository associated with it. And now everything in Git is a workspace. Now, once again, that might lead to another question, that if I say everything is a workspace, you always need a place from which you have to start doing some changes, right? Because a normal workspace is nothing but a work directory where a user will be doing the changes. But where is that you're going to store everything where every person can share? So that is when we will be following the methodology of centralized model, where we will take only the concept, in which what we will do is, we will take a copy of a workspace and we will keep that workspace as a centralized workspace. So now what we will do is, in Git, everything is a workspace. That is first. And second thing is, every workspace will have a repository inside it. And now, by saying it, what we will do is, we will take one particular repository or one workspace, and that workspace, we will mark it as a centralized workspace. Why is that we have to do? It is because now that workspace which is going to act as a centralized workspace is used only for sharing the contents. So that now, if a user wants to do some changes, what he will do is, he will try to create a workspace based on this central workspace. And in that, what he will get is, he will get the complete content of whatever you have in the central workspace. So that now, he can do the changes whatever he wants in his workspace, and when he wants to share it with others, then he will first share it to the central workspace, so that others will try to take the changes from this central workspace. So that is the same concept of how you are going to do. But the advantage here what you have is, you will have a copy of a repository inside each workspace. So that is when you will be having one workspace which is going to be treated as a central workspace. And what is the purpose? The purpose of that workspace is to only store the change and share the change. So now, if a user wants to do some change, then he will try to create his workspace, which is nothing but a copy of this particular workspace. Now, when he creates his own workspace for doing the changes or development activity, he will be getting all the files that you have in the central workspace, and along with it, you will also get a copy of the repository inside his workspace. So that way, every user who creates his workspace will get a copy of the repository based on what central workspace he is creating. So now the advantage here is, unlike this, you don't have to worry anything about being on the network. So you have a copy of the repository in the same directory. So you can see the file, and any operations that you do, it will be very fast because you are not taking anything to view from the central workspace. You have a copy of the workspace repository inside your workspace. So that is how the operations will be quite quicker, because if you want to get some data, you are going to get the data from the repository which is available on the same workspace. So that is how the checkout and the check-in concepts is going to be very faster, because every workspace will have its own copy of the repository. So that way, now a user can continue to do the changes, and he can store all the changes in his own workspace where there is a repository that will be getting stored all the details. And whenever now he wants to share the changes with others, he will be sharing it to the central workspace. So that now, if this person wants to share changes with another person, he can directly share between it, or he can share it to the central workspace so that he don't have to worry who is asking him. So that way, where you can directly share the changes between the user's workspace or between the user's workspace and the central workspace, is what we call it as a distributed model. So that is when we have an advantage where every user who creates a workspace will have a copy of the repository. But the difference is, in this workspace where the user has created, he will have the ability to see the file, modify the file, and store the file. Whereas the central workspace will also have a copy of the repository, but you cannot see any file in it or modify any file. The only necessity of the central workspace is to store the changes. Okay, so that's the difference that we need to understand. So be clear in this. The first thing is, in Git, everything is a workspace, and every workspace in Git will have a copy of a repository. And basically, we will have two types of workspace. One is central workspace, and the other one is the user or the local workspace, where the central workspace is used to store all the changes and share the changes, whereas the local workspace is used to modify, edit, or store and share. Okay, so that's the major difference on what are the advantages that you will be getting. Okay, so now when I say that, basically every copy of the workspace is going to have a repository, which means every workspace that you're going to create will ideally have a repository inside it. Now, by saying it, then there might be a problem that all the information, that is the references that we are creating, will be stored internally, right? Here in the centralized model, I was saying, you will be having all the references that a person does when he does a check-in will be stored here. Now, when I say that every workspace has a copy of the repository, then all these references will actually be stored inside it. So will it not be a huge problem and the storage problem where you are not only able to see the files, but you are having the complete repository in this workspace? So that is when what we need to understand is how Git is trying to store the changes. Okay, so pretty much now Git uses a concept called snapshot. So what do you mean by snapshot? So you might have heard this word a lot of time in your mobile or in your PC, where you try to take an instance or a reference at that particular point of time. So let's say that you are working on a web page and you want a screenshot of it, right? So at that point of time, what do you exactly have? So that is what we refer it as snapshot. So how does Git uses it? Now what Git does is, whenever you do some change and you are trying to store it into the repository, what Git will do is, rather than storing the change directly, it will try to take the delta or the difference between what you already had and what is that you have modified. Okay, so only the difference it will try to take a snapshot, and that too, it will not take the complete content. It will take only the snapshot reference of what you already had and what is that you're trying to put. Okay, so that terminology is what we call it as snapshot. So using the snapshot, it will be trying to store all the details. So at any point of time, if you want to know who did the change, what change he did, and when he did, internally, it will be through the snapshot what it creates. So as soon as a user does a modification and he is requesting the Git to store the changes into the repository, he is not going to store the changes directly, whereas the Git will take a snapshot, which is nothing but the delta difference of what he already had and what is that he is trying to modify, and that snapshot difference is what it is going to store. So that is why the repository that you're going to have inside your Git workspace will not be huge. So it is very lightweight. Okay, unlike other repositories that you've been using in Subversion, Perforce, or ClearCase, the Git repository is very lightweight because you're not storing everything as a file. You're just storing the snapshot difference between what you did and what you already had. Okay. Next. So in Git, when you do the check-in, that is after you modify, you are supposed to do the changes to be stored into the repository, right? That is what we call it as check-in that we understood from the last session. A check-in is nothing but in your workspace, you do some change and you want to store that change as a reference inside your repository. So in the same way, now, if you take a particular workspace on your working, you will do the change, and when you try to do a check-in, it will try to store the reference in terms of snapshot into the particular repository which is available in his workspace. So now in Git, we don't call it as a check-in. Instead, we call it as a term called as commit ID. In fact, check-in is referred as a concept of commit. Check-in or commit both refers to the same terminology where you are trying to take the changes that you have done in your workspace and you are trying to store it inside your repository. Now, every time when a user does a commit, there will be a reference created inside the repository. Once again, that we saw from the last session, and that is what we call it as a version. And specifically in Git, we call that as a commit ID. Okay. So, okay, I had someone asking the question, what is snapshot? Now, to be clear once again, so what is a snapshot? At that particular point of time, what is that you have? So when I say the relation between what you do in Git is, you will have some file and some content already stored in the repository, and you are trying to do some change on top of that. So you will do a checkout, take the changes from the repository inside your workspace, and that is the directory, and do the changes. And once you do the change, you will try to do the check-in. That is the concept that we were trying to see yesterday. Now, when you try to do a check-in or a commit in Git, what Git does is, it will not directly take all the changes or the complete file and store. So what it will be doing is, practically, it will be taking only the difference of what you already had and what you have modified now, and that too, not the content, but only the snapshot reference. Okay, it's just like a screenshot copy that you take that will tell you what exactly you had at that time. Same way, what you already had and what you have modified, that screenshot or a snapshot is what Git is going to take, and that is the reference that it will be storing it every time you do a check-in or commit. Okay. So that way, every time when you do a check-in or a commit in Git, you will be actually creating a version or a reference. And that reference in Git is what we call it as a commit ID. So why is it important that we should know? Now, commit ID is the reference which Git is going to exactly store. And only with respect to that, we will be able to track on what exactly the changes has been done, who exactly modified it, and what and all you have modified. Okay, so every time you do the modification and do the check-in or commit, Git will be creating a commit ID. So what exactly is this commit ID? As I said, a commit ID is a reference which the Git will be using to track the changes. Now, for us, if you look, a commit ID will be a 40 long characters that the commit will be creating. So every time a Git does a commit, you will be getting a 40 long characters that is unique. So every time a user does a commit with some change, every time for the commit, there will be a unique 40 characters that will be created, and that is what we call it as a commit ID. Okay, and this ID cannot be changed or manipulated because it is going to refer internally to the set of changes that you have. So that way, every commit ID that we are going to create will be having certain factors, like the first thing that the commit ID refers is the snapshot of that particular change. Because what is that you are doing? You are doing a commit. What is the purpose of commit? You have modified something, right? And in that way, what is that you have modified? So that reference will be taken care by creating a snapshot. Okay, so that is when a commit ID is nothing but a 40 characters, which is a unique ID, which is being created by Git and stored by Git, which will have the details about who is modifying it and what he has modified and when he has modified. Okay, so that way the commit ID, every time a user does a commit, it will have the details about what is the snapshot. Snapshot means now we can get what is the changes that you have done. So that is how it is going to store the snapshot, not the content of the file. The next thing, who is the author of the changes that has done? Okay, then the committer. Kavya, commit ID, once again, if you are not clear, commit ID is not the username. When a person does a commit in his repository or his workspace, Git is going to create a 40 character. Okay, that is a unique ID which Git will be using to recognize or to track what that person has done. Okay, it's just like, if you're trying to write an exam, you will be given a unique ID, right? That ID is not your name. That is the ID which refers to who is the person, what is the exam is going to write, and for what particular subject you are going to write. In the same way, every time when a person does a commit in a Git, what Git will do is it will uniquely create a 40 characters, which is the ID using which you will be tracking everything. And that ID will be actually consisting of several factors, that is the snapshot of the changes what you have done, then who is the person who is trying to do the commit, and then what is the date and time on which you have done the commit. And top of that, you will also give something called as a commit message, where it is going to be helpful to know whether the person is doing a change for a particular reason. Because at any point of time, if you look at the commit ID, it is going to be a 40 characters. So it is going to be a combination of number and some kind of alphabets that is unique to Git that we won't be understanding. But how is that I can know who modified? So that is what the commit ID is going to have, all these details. Okay. Now, commit ID, once again, Kavya, if you're not clear, it is just a random number which Git is going to create. It is nothing related to a company. Okay, so it is going to be a random number which it is going to create. So it is a random 40 characters which is going to be created uniquely for every person who is going to create a commit. In that commit ID will be having the details about who is the person who modified. Now that depends on which company are you working in. That company, what is the person's name that has been given to work. So that details will be stored. Okay. So a commit ID is the actual reference using which Git will be storing everything. And if you look at a commit ID, what and all details you will be having in it. You will be having the details about who is the person who is doing the commit, what date and time he did, what exactly changes that he did, that we will be getting from the snapshot, as well as what is the reason on why you are doing this. So that we call it as a commit message. So all those things will be stored together as one commit ID. Okay, so like this, every person who does a change on a workspace, it will be clearly tracking with a unique 40 characters that is referred as a commit ID. So if you are going to do changes 4 times and you're going to do 4 check-ins or 4 commits, in Git, the repository will contain 4 unique 40 characters, where each 40 unique character will be representing at that point of time who modified, what he modified, when was the date and time it was modified, and what is the purpose on which you are modifying. All those things will be tracked. So that is how we will be able to easily know who exactly is modifying and what has been modified. Okay. Now, when I was talking about Git, so I said one thing, that in Git, everything is a workspace. And second thing, in Git, you will also have a repository in every workspace. So that way, now if you try to do a deeper dive into a workspace. So if you open a Git workspace, what and all do you have inside it? So ideally, when I say a workspace, it is nothing but a directory in your operating system or a folder in terms of Windows that you call. So if you go inside a Git workspace or a Git directory or a folder, you will be basically having 3 areas inside it. Okay. So what are the 3 areas that you have inside it? The first area that we will have inside it is called as a working directory or a working folder. So what is the need of this working directory? The working directory is the location inside your workspace where you will be actually doing the changes, where you can see the file and modify the file. So remember, in a Git workspace, it is an area called working directory. Only in that place you will be able to see the files and modify the files. Okay. The next thing, as we know that in Git workspace, you will also have a repository inside it. So that is when in the workspace, there is a second area called Git directory, where this Git directory is what going to be acting as a repository for that workspace. Okay, so that is the second area where any changes that you do will be getting stored into this place which acts as a repository. So the second area that you have inside your Git workspace is Git directory. So now, what happens when a user does changes is, basically, first the user will be going inside his workspace. In his workspace, he will be able to see the files and modify the files from working directory. And once he does the change, then he has to do a check-in so that everything will get stored into the Git directory or the repository. But we now know that if you want to do a commit ID requires the snapshot, right? Only then it will be taking a reference of what exactly changes we have done. So for that purpose, we have one more area inside your workspace that is called as a staging area. Now, staging area is actually a buffer area, which means you cannot see the directory or you cannot see this workspace inside your Git workspace. Okay, but logically it is present there. So what is the necessity of this? So now, if you are trying to do the check-in or commit concept in Git, then it is not directly taking the changes what you have done here and putting it inside to the repository. So in Git, the check-in has to happen in 2 steps, where the first step what you will do is, in your working directory, you will modify the file, and from this directory, you will take those changes and put it into the staging area, where as soon as you put the changes into the staging area, Git will be taking the snapshot of the references on the difference what you have done. Okay, so that is when, as soon as you have done the changes, the first step that you have to do is put into the staging area. Then after you have put into the staging area, then you have to do the actual check-in or commit, where what Git will do is it will take the snapshot reference what you have tried to put here, and with respect to that, what is the user who is doing the change and at what time he is trying to do the change. It will collect all those information along with the snapshot that it has created in the staging area. It will try to create a unique 40 characters, which is the commit ID. So that is how the workflow is. First, user will do the modification in his working directory, and then he will take the changes and put into the staging area, where the Git will take the snapshot. And after that, from the staging area, we will be actually doing the commit, so that we will take the commit process for which the Git will take the snapshot from the staging area, and then it will take the other details on who is the user who is doing it and what is the date and time and the message, and with a combination of all these things, it will be creating a unique ID which will be 40 characters. And at any point of time, using that unique 40 characters, which is the commit ID, we can know what was done in that and who did this change and what and all are the change that we did. Okay, so that is what you are going to have. So remember, if you go into a Git workspace, you will be having these three areas, and the workflow that you have to follow is first modify here, then put into the staging area, and then from here you do the actual commit where it will be storing into the repository. And all these things are going to be part of your single workspace. Okay, so don't think that everything is going to be separate. So if you create a workspace, okay, now you are going to have all these three things together. Mujahid, that is what I was trying to tell you, that when you want to create a commit ID, you need a snapshot. Only with that reference, it can tell you what has been modified. So that is when you cannot directly do a change and put into the repository. So if you have to do the commit, the first thing that you have to do is take the changes from the working directory and put into the staging area, where only in the staging area, Git will be taking the snapshot. So for doing a commit, you need one of the factor, that is the snapshot. That is how it is going to track everything, right? So that is what you are going to get by putting the changes into the staging area. So that is how there is a two-step of commit, where you do the changes first, put into the staging area, where it will take the snapshot of what you already had and what you have modified now. Only that difference snapshot will be taken, and that will be considered as putting inside to the commit ID. Okay, so as I said, you need to remember that you will have all these three areas inside your workspace. So just to quickly say, now if you create a workspace in Git, let's call this as a Git workspace. Now every Git workspace will have three areas. So that is, the first one, you will have the working directory, and then you will have the buffer area called the staging area, and then you will be having the repository where you're going to store everything. Okay, so the first area that you're going to have is your working directory, and then you will have the staging area, and then you will have the repository, where in this particular working directory, you will be actually seeing the files and doing the modification. And once you have done, what we will do is we will try to put the changes from the working directory to the staging area. And in the staging area, what we will do is we will take the snapshot reference of what you already had and what you have modified. And once you have done the changes, then you will be trying to do the commit, where in the commit, what we will be doing is we will be creating a unique 40 characters, which we call it as commit ID. Okay, so you will be creating commit ID 1, commit ID 2, like this, where each one of them will be 40 characters, which is unique to the reference, where each one of them will refer to a particular snapshot and the changes what it has been done. So remember, everything together is what we call it as one Git workspace. It is not separate directories. Everything is inside one directory under your workspace. Okay. So that way, the only thing that we now need to understand in the Git is what is the life cycle of the Git files that you're going to undergo. Now, when you consider a repository, any kind of repository, you will not be having everything there, right? Basically, you have to always start from scratch, no matter whatever it is. So that way, when you first create a workspace or a repository, so internally now, whenever I say that you are creating a workspace, we now know that in Git, a workspace comes along with the repository. So that is when I say a workspace, it will always have a repository inside it. So you can either call it as a repository or a workspace. Both are pointing to the same directory. Okay. So that way, when we create a new workspace, that will always have a repository and that will be empty. That is the first time that you're going to do. So now, when you try to put a file inside it, the first thing that you will be doing is putting the file inside the working directory. Because this is the only place where we can see the files and modify the files. I cannot go inside any other place and do modification. This is the only area that we have to use to see the file and modify the file. So that is when first we will try to create a file in this working directory. So now when you create a file in your working directory, and that is a very fresh file or a new file, and there is no details about it in the repository, or your repository is completely empty when you start for the first time, right? So that is when what Git will be considering is any new files that you are trying to put inside your working directory will be called as untracked file. That is because there is no detail about that in the repository. So what do you mean by tracking? Tracking means we know something about it, right? So if you say that, hey, I know certain details about it and I'm trying to follow that guy, that means you know much details about him or a particular person or a particular data. That is how in Git, with the reference of the commit ID, it will be trying to track saying that, hey, you did some change. That is because I already know that this is the content what you had in this file, and top of that you are trying to do. So that is when a file will be tracked in terms of the commit ID and internally the snapshot. Whereas if you're trying to put a new file, what will happen is there is no reference about that file in the repository. Hence, the file will be called as a untracked file. So remember, a new file that you're trying to put inside the repository will be basically considered as an untracked file because there is no information about that file in the repository. So whenever you first have a file, you will put into the staging area, and as soon as you put the files into the staging area, then the file will be considered as a staged file. Okay. And then what will happen is when you try to store the change from the staging area to the commit ID, now the file has been tracked inside the repository using commit ID. So that is how the status of the file will now be considered as unmodified. That is because whatever content you have in the repository is the same content that you have inside your working directory. So from the untracked status, you are going to make it as a staged status, and then the file will be marked as unmodified, because when it compares with the working directory's content and what it has in the commit in the repository, there is no difference. So that is how going forward the file will be called as a tracked file. And when you say a track, you are not going to say that I know the information. Specifically, you are going to say what is the status of the file. So that is when you create a workspace and on an existing file, if you try to do some modification, what Git will do is it will try to compare the content what it has in the repository with what it has in the working directory. And in case if there is any difference, then the status of the file or the files will be called as modified. Okay, so modified means it knows about the file, right? That is how you are going to say it is modified, because without knowing anything about it, you cannot say whether it is modified or unmodified. So a modified means the file has been tracked by the repository or Git. In that way, when you do some change, first the Git will be considering the file as modified. And then when you put the file into the staging area, the status of the file will be called as staged files. And then when you try to do the commit, the file will stored into the repository with the reference of commit ID. And in that, you are going to change the status where the file will be called as unmodified, because whatever that you have now in the working directory, the same thing has been stored into the repository. So there is no difference between these two. Hence, the file will be called as a unmodified. So remember, any new file that you're trying to put into the repository, for the first time it will be called as untracked. But as soon as it has a reference into the repository, then it will be called as unmodified or modified or staged based on what you have in it. If there is no difference between what you have, the file that you're looking at in the working directory versus what it has in the repository, then it is called as unmodified. And as soon as you do the modification, then when it compares between what you have in the working directory versus what it already had in the repository, then you are considering the file as modified. And once you do the staging, it will create a snapshot. And after that, when you put a commit, now whatever that you have here is being stored permanently into the repository. So that is how the file will be called as unmodified, because there is no difference. Okay, so this is the life cycle of a file or a directory that you do changes. And the next thing that you need to know is, in Git, you will be working on the working directory. And once you have done the changes, you will put into the staging area where it will create a snapshot. And then finally, you will try to do a commit where it will take the snapshot reference and create a unique 40 characters, which is called as commit ID. Okay, so this is the workflow and the fundamentals that you need to understand, because as we keep going on into the practicals, we will be talking only about this itself. So be clear. So any questions or doubts before I jump on into the practical and show you everything on what is a workspace, what are the areas that you're going to have inside the workspace, and what is the purpose of each one of them? How is that you're going to do a commit, and what happens when you do a commit, and how exactly the commit will be storing? So that we will see all those things in the practical on how to create and what exactly each one of them, what commands you will be using.